Right everyone, welcome to the next maximum power transfer theorem. So here the first look at the statement. A resistive load, yes, this is the resistive load. A resistive load will abstract the maximum power from network. This particular resistive load, maximum power taken from the network when it is possible, when the load resistance is equivalent to, very important, when load resistance is equivalent to the network viewed from the output terminals. That means load resistance is equal to the source resistance, then maximum power transformation is possible. Maximum power transfer from one source to load. That is a maximum power transfer theorem. With all energy sources are removed, leaving behind their internal resistances. Removing and remained all energy sources are removed, leaving behind their internal resistances. So with the help of the example, I will explain the maximum power transfer theorem. So here first I will give the derivation. I will prove that load resistance is equal to source resistance. Then in the next after 5 minutes derivation is completed, after that we will look at the one example problem. You know how to find out the load resistance is equivalent to source resistance concept, same as the RTH concepts. The same thing here, source resistance removed and replaced by the internal resistances. That means RTH procedure is same as the load here also, to find out the load resistance is equal to source resistance. Okay, let it be. Coming to the derivation proof. In the examination, you are writing object examination. Proof is not required for you, but you make you understand the concept behind the maximum power transfer theorem. Then it is easy to remember the condition. Okay, sir already explained the derivation. Source resistance is equal to load resistance. I know the derivation. Then you will get the idea about in the examination, RL, load resistance is equal to source resistance, maximum power transfer theorem. Okay. Maximum basic questions only they will ask in the examination, but your preparation will be the maximum 360 degrees round preparation is required to crack your examination. Okay, so this particular circuit I have, this is a E, RG, internal resistance of source, R, this is a network. So to transfer the maximum power from this particular source to load resistance is equal to source resistance. I need to prove that. So first of all, I am going to give current. The current flowing through this circuit, I is equal to, that current I is equal to E, voltage divided by, this is a series circuit, right? These three are connected in series. So this is internal resistance, just I am timing and neglecting. Only this R and this RL, how it is connected in series. Okay. Now this is a I. Power formula P is equal to I square RL, because you need to calculate the power calculations, maximum power transfer theorem, right? So here replaced I by E square divided by, I in replaced here, E square divided by R plus RL whole square. Here RL is there. This is the actual power formula. To maximize the power, to derive derivative, so apply the differentiation. To maximize the power, to maximum power condition, to need to derive PL, this is the power, load power, PL divided by RL, derivative with respect to RL, you will get the maximum power that may be equivalent to 0. You will get the ideal condition. What is the load resistance is equal to source resistance condition. So just make your calculations here. dP, derivative of PL divided by RL is equal to, E square is a constant, right? Next one, here E square is constant, 1 by U by V rule you can apply derivative. I hope that everyone know the derivations, U by V formula. So derivative of RL is 1. Okay, the first part is n plus UV rule. derivative of denominator, that means here RL u into derivative of denominator. This is a power 2, right? 1 by x square, that make you x to the power of minus 2. That may be 2 into x to the power of minus 3. Yes or no? In the same case, same condition here I'm going to apply. RL 1 divided here 2, right? In the power minus 2. That means minus 2 divided by R plus RL to the power of 3. Because minus 3 in the denominator plus 3. Okay, fine. This is about the calculations. Now, this total entire equation make it is 0, right? 0. E square, this side also 0 divided by e square 0 only. Coming to here, I will simplify the equation. R plus RL whole square minus RL divided by R plus RL to the power of 3. Is it okay? Now 0 LCM is R plus RL cube, right? Here R plus RL, right? This is because this is the one time to the power of 2 the square. Here one time, that is RL. Okay. Now total entire here 2 is there, no? 2. Here 2, we have forgot 2, right? Now 0 is equivalent to 0 into R plus R cube is 0 only. R plus RL. Here RL minus 2RL is equal to minus RL. Make the erase here. Okay. R plus R minus RL. Finally, R is equal to load resistance is equal to source resistance. This is a proven. So whenever maximum power transformation is possible, whenever source resistance is equal to load resistance. So finally, the formula to find out the maximum power across the load, E square divided by RL divided by 4 RL square. Okay, how you get this equation? Just this relation substitute in this formula, then you will get this relation. I hope that I don't want to do, you want to do. Okay, I will make you that calculations also for your understanding purpose. Okay, how I got this equation? See here, I have equation E square divided by RL divided by RL plus R square. This formula. Just substitute this condition here. E square divided by E square into RL divided by RL and R both are equal. Replaced here 2 RL whole square. That may be equivalent to E square RL divided by 4 RL square. So this RL, this one RL get cancelled. So what is the finally you got? E square divided by, there is no RL, E square divided by 4 RL. This is the maximum power formula to find out the maximum power. So this is a maximum power formula. PL square is equal to E square divided by 4. Example 4.7. In the circuit shown in the figure, this is a circuit. Find the value of load resistance RL. This is a value you want, right? So this value you want to find out, right? So terminals A and B which abstract the maximum power from the circuit. Also find the maximum power. So in this case, you are attending the KVS examination, right? The KVS examination is an objective type examination. You need not to be solve step 1, step 2. It is not like that. That's why I will explain in the objective manner only. See here, you want to find out load current RL, load resistance RL. So whenever the maximum power will be transferred from source to load, source resistance will be equivalent to load resistance. For that case, we have to find out that particular resistance. Just short circuit the voltage sources and open circuit the current sources, same as Thevenin's resistance. Remaining all other 4 ohms, right? And this terminal should be open circuited. Here look at the resistance between these two terminals is nothing but a RL, load resistance, because we are given maximum power condition. Thus we are applying this particular thing. So these two are connected in parallel. After that it is connected in series. So 3 into 6 by 3 plus 6 plus 4. This is a series. In the examination, these can directly write it. 2 plus 4, it is equal to 6 ohms. What is the load resistance? RL is equal to 6 ohms. So the first problem, the first part of the problem is completed. Next, what is the second part? The second part here, maximum power, P maximum you need to calculate. So for that calculation of P maximum, the formula is VTH square divided by 4 RL or RTH. So load resistance, right? So RL you need to replace it. This is the formula, RL value is 6 ohms, What about VTH? VTH is nothing but open circuit voltage across these terminals, right? So I have to calculate the voltage between these two terminals, right? So I need to copy this one. So these two terminals are disconnected from the circuit, right? So you can calculate the voltage between these two terminals is nothing but a Thevenin's voltage, the otherwise open circuit voltage. How to find out? Whenever it is open circuited, what about the current here? 0. Whenever current is 0, the voltage across these two terminals is nothing but a VTH. So this is a series circuit. In the series circuit, voltage is divided. So how to find out the voltage? That is equal to total voltage into, same resistance divided by total resistance, 3 plus 6. This is the voltage division rule concept. So that will be equivalent to 24 volt. Okay. So I got VTH value. Finally, I want P maximum is equal to VTH 24 into 24 square, right? VTH square divided by here 4 into 6. 4 here, 6 is a RL. So this will be 1 time. 6 4s are 24. So finally 24 watts. Okay, this is about the solution for this problem. In the examination point of view, either they will ask the load resistance, otherwise they are asked both. What is the maximum power transfer? So if they are asking the maximum power transfer is 24 watts. If you are asking for load resistance, that is this is a P maximum. In the options they are providing, and P maximum is equal to, as well as load resistance is equal to 6 ohms. Okay, this is the condition. If you are increasing the load resistance more than or less than this we won't get maximum power 24 watt, less than that only. This is the maximum limit. Okay.